Dear students, today we study about work, energy and power. So we have the new chapter related to work, energy and power. So what does it mean work? So how to measure work and how to find or measure energy and power. So we can study over here in this chapter. So let's see, first of all, main points, write down main points which are related with work, energy and power. So if the work means what? The work, which is also known as work done by body. This work means work done by body. So write down work done is equal to, what is the formula? So we can see three cases over here. So work done means the force into displacement. You can write down D or S. So S is the displacement and F is the force. So when actually work done is the product of force applied on the body and distance covered by body in the direction of force. यदि हामीले कुनै एउटा अब्जेक्टमा एउटा फोर्स अप्लाई गर्यौं र यसले s डिस्टेन्स कभर गर्यो, अप्लाई गरिएकै डिरेक्सनमा सम डिस्प्लेसमेन्ट भयो भने we can write down F into S. So this is one of the case, and another case is work done is equal to F times S, but it is in minus sign. So this is minus sign. So at what condition we put minus sign? So for this, यदि हामीले कुनै एउटा अब्जेक्टमा फोर्स यता अप्लाई गर्यौं, यो फोर्स अप्लाइड हो, त्यो अब्जेक्टमा यो डिरेक्सनमा फोर्स अप्लाई गर्दा त्यो अब्जेक्टले यो डिरेक्सनमा डिस्टेन्स मुभ गर्यो भने, यसको अगेन्स्टमा डिस्टेन्स मुभ गर्यो भने we can write down as minus F into S. यसमा अप्लाइड गरिएको फोर्स र यसले कभर गरेको डिस्प्लेसमेन्ट जस्ट अपोजिट छ. त्यो अपोजिट भएको बेलामा यो S को चाहिँ हाम्रो चाहिँ यो डिस्प्लेसमेन्ट यता छ, डिस्प्लेसमेन्ट अथवा मुभमेन्ट अफ द बडी नेक्स्ट साइडमा उतापट्टि छ भने तर फोर्स अप्लाइड चाहिँ हाम्रो यतापट्टि छ, जस्ट अपोजिट छ. यसमा फोर्स अप्लाई पनि यता छ, डिस्प्लेसमेन्ट पनि यतै छ. सो इट इज इन सेम डिरेक्सन. सो सेम डिरेक्सन भएको बेलामा फोर्स र डिस्प्लेसमेन्ट सेम डिरेक्सन भएको बेलामा we put positive sign, and if the force is applied and displacement is just against the force applied on the body, if they are opposite direction, then we can write down minus sign. So in third case, the work done is equal to F cos theta in times S. यदि हामीले यो केसमा चाहिँ कुनै एउटा अब्जेक्टमा हामीले फोर्स यसरी अप्लाई गर्यौं, यो डिरेक्सनमा हामीले फोर्स अप्लाई गर्यौं र डिस्प्लेसमेन्ट हाम्रो सर्टन एंगल बनाएर यतापट्टि छ भने अप्लाई गरिएको फोर्स यो डिरेक्सनमा अनि त्यसपछि डिस्प्लेसमेन्ट हाम्रो यो होरिजेन्टल लाइनमा छ भने, सो इट मेक्स सम एंगल ओभर हियर, कुनै एउटा एंगल बन्छ र यो केसमा हाम्रो यो F ले होरिजेन्टल लाइनसँग बनाएको एंगलको आधारमा this will be F cos theta, this will be F cos theta times S. So horizontal component is F cos theta into displacement. So displacement means S. So if you multiply, or the product of this force and displacement is altogether becomes work done by body. So तीनवटा केसमा हामीले यसरी फर्मुलाहरु देखाउन सक्छौं. So remember this formula when you are using work done by body. And fourth formula is related with energy. Energy, as you know that energy is the capacity of doing work. So its work, the SI unit of work is joule. Similar as the SI unit of energy is also joule. Energy ला पनि हामी joule मा लेख्छौं, work ला पनि joule मा लेख्छौं. Energy मा हामी two types को energy study गर्छौं. So one is kinetic energy, another one is potential energy. So kinetic energy भन्ने बित्तिकै त्यो कुनै पनि बडी मुभिङ भएको बेलामा, मोसनमा भएको बेलामा त्यसले गर्न सक्ने, त्यसले गर्ने or capacity of doing work when object is in motion. जुन मोसनमा छ त्यति बेला त्यसले गर्न सक्ने त्यसको क्यापेसिटीलाई हामी इनर्जी भन्छौं, जसलाई जुलमा एक्सप्रेस गरिन्छ। र पोटेन्शियल इनर्जी भनेको when object is in rest, कुनै अब्जेक्ट रेस्टमा भएको बेलामा त्यसले गर्न सक्ने उसको क्यापेसिटी अफ और इफिसिएन्सी अफ डुइङ वर्कलाई हामी पोटेन्शियल इनर्जी भन्छौं। सो काइनेटिक इनर्जी अफ अ बडी is equal to half mv square. So this is the formula to find kinetic energy of any body or particle. So half m means here, m means mass and v means velocity of that object. So half into m into v square, if you apply this one, then you will get kinetic energy. So similarly, potential energy of a body. Potential energy of the body. So for this we can write down mgh, where m is the mass of the object, g is the gravity or acceleration due to gravity, simply gravity you can say, and h is the height of the object from the ground. Ground बाट कति हाइटमा त्यो अब्जेक्ट छ त्यसलाई हामी पोटेन्शियल इनर्जी भन्छौं। सर्टेन एउटा पोजिसनबाट ग्राउन्डमा, यो ग्राउन्ड, इट इज ग्राउन्ड, सो यहाँ जति हाइट कभर गर्छ दिस इज हाइट, दिस एच इज दिस वान। सो सम डिस्टेन्स अवे फ्रम ग्राउन्ड, फ्रम एनी पोइन्ट, कुनै एउटा पोइन्टबाट ग्राउन्डसम्मको हाइटलाई अथवा डिस्टेन्सलाई हामी एच भन्छौं। कुनै एउटा अब्जेक्ट हामीले यहाँबाट थ्रो गर्दैछौं अथवा कुनै एउटा रेस्ट पोजिसनबाट थ्रो गर्दैछौं भने त्यो अब्जेक्टको मास m भइहाल्यो र यसलाई यसको यो अब्जेक्टलाई एउटा सर्टन ग्राभिटी फोर्स अफ एट्र्याक्सन अथवा ग्राभिटीले यसलाई चाहिँ डाउनमा पुल गरिरहेको हुन्छ। सो दिस इज एक्सेलरेसन ड्यू टु ग्राभिटी। सो इन दिस वे वी क्यान फाइन्ड आउट द पोटेन्शियल एनर्जी अफ अ बडी। एक्चुअली पोटेन्शियल एनर्जी अल्सो फोर्स इन्टु डिस्प्लेसमेन्ट। फोर्स मिन्स इट इज वेट, जति वेटले यसलाई, जसको जति वेट हुन्छ त्यति नै फोर्सले यसलाई तानेको हुन्छ। सो पुलिङ फोर्स इज known as work done. So work done is mg, and displacement means it is the height, the covered distance covered by body from this position to this position. So displacement भनेको यो केसमा h हुन्छ र weight र displacement को मल्टिप्लाई नै हाम्रो पोटेन्शियल इनर्जी हुन्छ। यो केसमा हामी यसरी सल्भ गर्छौं। र पावर, so we have also some relation for power. So power is expressed in what? So we can write down P also. What मा एक्सप्रेस गरिन्छ? Power means rate of doing work. यो काम गर्ने वर्क को रेट कस्तो छ भनेर हामी यसलाई मेजर गर्छौं। सो वर्क डन, काम गर्नेको रेट भएको हुनाले वर्क डन, एन्ड रेट भन्ने बित्तिकै यहाँ तल के हुन्छ? टाइम टेकन हुन्छ। टाइम टेकन पर सेकेन्डमा त्यसले कति काम गर्न सक्छ, हरेक सेकेन्डमा उसले गर्न सक्ने कामको कम्पेयर गरिन्छ यसमा, हर मिनेटमा अथवा हरेक सेकेन्डमा, इन इच सेकेन्ड और इन इच मिनेट। इफ इट इज इट क्यान डू सम जूल अफ वर्क, देन इट इज द रेट। सो इट इज रेट अफ डुइङ वर्क। रेट मिन्स डिभाइड dt विथ रेस्पेक्ट टु टाइम टेकन। सो वी क्यान कम्पेयर विथ रेस्पेक्ट टु टी, टाइमको बेसमा यसले गर्न सक्ने वर्कलाई यदि हामीले रेट मेजरमा कन्भर्ट गर्यो भने द्याट बिकम्स power. So this formula also we can write down as work done भन्ने बित्तिकै अब हामी यहाँ F into D पनि लेख्न सक्छौं, S पनि लेख्न सक्छौं, D नै लेखौं, अनि टाइम टेकन भनेको T लेख्न सक्छौं। In shortcut we can write it as like this, and यो फर्मुलालाई हामी यसरी पनि बनाउन सक्छौं। P is equal to F भनेको हाम्रो mg हुन्छ र D को D छँदैछ, mg D by T हुन्छ। यो फर्मुला पनि हामी एक्सप्रेस गर्न सक्छौं यसैबाट डिड्युस भएको फर्मुला, अथवा यस्तो फर्मुला पनि युज गर्न सक्छौं। P is equal to mg, अब डिस्टेन्स बाइ टाइम टेकन भनेको v हुन्छ, mg v पनि लेख्न सकिन्छ। d by t भनेको भेलोसिटी, भेलोसिटी भनेको डिस्प्लेसमेन्ट अपन टाइम टेकन। सो d by t means it is v, mg v पनि लेख्न सकिन्छ। So in this way we can interpret all the formula for power. So these are the formula you have to remember or keep in mind to solve the question. Now we are going to study principle of conservation of energy. So this is one of the topics which is very, very important. So what does principle of conservation of energy say? Now let's see. So this is the one question comes from this chapter. Prove that sum of kinetic energy, that means Ke, and potential energy of a moving body, this is moving body, sum of kinetic energy and potential energy of moving body remains constant throughout the motion. कुनै पनि अब्जेक्ट जुनसुकै स्ट्यान्डमा जुनसुकै समयमा लिए पनि त्यसको टोटल काइनेटिक एनर्जी र पोटेन्शियल एनर्जीको सम अर्थात् टोटल अलवेज सेम हुन्छ अथवा कन्स्ट्यान्ट हुन्छ भनेर हामीले देखाउनु पर्यो। जुनसुकै पोइन्टमा हामीले मोबिलाइज गरे पनि माथि एउटा सर्टन पोइन्टबाट ड्रप गर्दा त्यसको एट एनी इन्स्ट्यान्ट कुनै पनि टाइममा हामीले लिएको कुनै एउटा सर्टन पोइन्टमा लिएको त्यसको केई र पी, द्याट मिन्स काइनेटिक एनर्जी एन्ड पोटेन्शियल एनर्जी इज अलवेज सेम। हामी देख्न सक्छौँ त्यो अलवेज सेम हुन्छ र त्यही आधारमा यसलाई चाहिँ यो कन्स्ट्यान्ट हुन्छ भनेर हामी देखाउन सक्छौँ। सो वी क्यान प्रुभ दिस थियरम। सो दिस थियरम अर स्टेटमेन्ट इज नोन एज प्रिन्सिपल अफ कन्जर्भेसन अफ इनर्जी। जुन पोइन्टमा हामीले इनर्जी लिए पनि त्यो इनर्जी सेम हुन्छ भन्ने कुरा हामी प्रुभ गर्दैछौँ। सो लेट्स प्रुभ दिस वान। सो वी क्यान सपोज any let one object is taken at the top of this position. So this is the position A भन्ने पोजिसनमा कुनै एउटा अब्जेक्ट छ जसको मास m छ हामीसँग र आफ्टर सर्टेन टाइम पछि यो C भन्ने पोइन्टमा पुग्यो। आफ्टर डिस्क्राइबिङ द डिस्टेन्स x डिस्टेन्स यसले कभर गर्यो C सम्म पुग्नको लागि र कुनै एउटा समयमा यहाँ पुग्यो र फाइनल्ली यो कुन पोइन्टमा पुग्यो B भन्ने पोइन्टमा पुग्यो which is ground. This is the ground. This is ground point. So ground को यो पोइन्टमा यो पुग्यो भने अब हाम्रो यसको टोटल हाइटलाई हामीले यदि h मान्यो भने this height will be h minus x भयो। यो हाइट चाहिँ h minus x भयो। So this distance is denoted by x. If total height is h, then it will be total minus this portion is equal to h minus x. So यसरी हामीले चाहिँ कुनै एउटा पार्टिकल यो स्टेपबाट स्टार्ट फलिङ, हाम्रो यो पोइन्ट ए बाट यो फलिङ गर्नको लागि सुरु गरेको छ र केही समयपछि यो सी मा पुग्यो र केही समयपछि इट रिचेज टु द ग्राउन्डमा पुग्यो भने त्यति बेला हामीले यो पोजिसन र यो पोजिसन, यो तीनवटा पोजिसनमा हामीले यो अब्जेक्टलाई स्टडी गर्छौं अथवा हरेक पोइन्टमा भन्न खोजेको हरेक स्टेपमा अथवा हरेक पोइन्टमा यसको के प्लस पी चाहिँ सेम हुन्छ भनेर हामी देखाउँदै छौं। सो लेट अ बडी अफ मास m is falling freely from a point A यो बडी कुनै पनि बडी मास m भएको बडी A बाट स्टार्ट भएको छ फलिङ हुनको लागि फ्रीली फ्रम अ पोइन्ट A let h be the total height after some time it reaches to the भन्नु पर्ने हैन, h be the total height of a body when it reaches to the ground. The body reaches at the point C, at any instant, and it covers x distance. So we can suppose, so let AB is equal to h भनेर हामीले मान्यौं, त्यस्तै हामीले AC is equal to x भनेर मान्यौं, then BC is equal to h minus x हुन्छ हाम्रो रिजल्ट। यहाँबाट रिजल्ट हेर्दा यो फर्ममा हामी आन्सर निकाल्न सक्छौं। AB लाई हामीले टोटल h भनेको हाम्रो टोटल हाइट अफ द बडी, जब A भन्ने पोइन्टबाट हामीले स्टार्ट गरेका छौं खसाल्नको लागि भने यो B सम्म पुग्दा लाग्ने हाइट चाहिँ h भयो एट एनी टाइम, र सर्टेन x टाइममा चाहिँ कुनै एउटा इन्स्ट्यान्ट पछि त्यो चाहिँ यदि C मा पुग्यो भने C सम्म यसले कभर गरेको डिस्टेन्स h हो, अथवा त्यो हाइट चाहिँ x हो भने BC को हाइट चाहिँ h minus x हो। So now let's study that object at this point, and this point. So at a point A, what happens? Now kinetic energy. So we can find out the kinetic energy of the same body at this point, and similarly potential energy also. So kinetic energy means half mv square, half into mass into half into mv square, it is the formula. So half into, it has some mass, and the velocity, its velocity, that means initial velocity is 0. यो हाम्रो यहाँबाट स्टार्ट भएको भएर हामीले भेलोसिटी हामीले के गर्छौं 0 गर्छौं, so it will be 0. Kinetic energy is at that point is 0, and potential energy is how much? So formula is mgh, and mass is same, gravity is also same, and it covers how much distance? So we have to suppose x distance, so it is mgx. PE को लागि at point A मा यो A भन्ने पोइन्ट ग्राउन्डबाट कति हाइटमा छ भन्ने लेख्नु पर्छ हामीले, x लेखेर हुँदैन, h हुन्छ। So this h means it is the same condition, so leave it mgh. So this h is the height of that particle from the ground. ग्राउन्डबाट यो A भन्ने पोइन्ट कति हाइटमा छ त्यो हाइट लेख्नु पर्ने भएको हुनाले h को h नै हुन्छ, यहाँ mgh हुन्छ। So now we can write down KE plus PE, and then we have KE is 0 and PE is mgh. So total sum of this one is mgh. A भन्ने पोइन्टमा त्यो अब्जेक्टको काइनेटिक एनर्जी र पोटेन्शियल एनर्जीको सम mgh हुन्छ। त्यसो भए C भन्ने पोइन्टमा के हुन्छ? अब now we are going to find the same process, same kinetic energy and potential energy at point C, not B. First of all C. So kinetic energy C मा पुग्दा यसको भेलोसिटी के हुन्छ? अब हाम्रो A बाट स्टार्ट भयो, B मा पुग्दा हाम्रो यसको भेलोसिटी कति हुन्छ भनेर हामी निकाल्छौं। So let V1 be the velocity of an object at C. C भन्ने पोइन्टमा त्यो अब्जेक्टको भेलोसिटी v1 छ भने we can write down the formula v1 square is equal to u square plus 2gh. So 2gh यो फर्ममा हामी चाहिँ लाउन सक्छौं, तर h को ठाउँमा अब हाम्रो के हामीसँग के छ? Distance covered by that body is, this is x, so write down x. So this is the formula, but u square is 0 here, so 0 plus 2gx. U means initial velocity. यदि अब्जेक्ट A बाट स्टार्ट भएको छ भने यति बेला इनिशियल भेलोसिटी 0 हुन्छ, and final velocity is v1. हामीले v1 हो भनेर सपोज गरेका छौं, so v1 is final velocity, so its value is 2gx. So finally its value is 2gx. So this is the value. And let's see kinetic energy. Now kinetic energy is equal to half mv square. Its velocity v square. So here is v1, so write down v1 half mv1 square. So half is half, mass that is same, and the value of v1 square is just we have to calculate this one 2gx. We have calculated v1 square, so write down 2gx. So 2 and 2 cancelled, and finally we get mgx. So this is kinetic energy. And potential energy, also we can calculate the potential energy of the same object at point C. अब यसमा चाहिँ mass is same, gravity is same, and the height means अब ground बाट कति height मा छ object भन्दा h minus x. So write down h minus x. So if you multiply this one mgh minus mgx, यसरी हामी multiply गर्न सक्छौं. mg र height from the ground, it is height from the ground हो, ground बाट h minus x को distance मा भएको भएर यो लेखेको. So if you multiply this and this, you will get this one. This into this means this. So in this way we can find out ke and pe. Now we can add both ke and pe. अब दुईटैको sum निकाल्न बाँकी छ. So let's see what will be the sum of ke and pe at this point. See. Now we can add both ke and pe over here. So therefore ke plus pe is equal to this one. The value of ke is mgx plus value of pe is mgh minus mgx. mgh minus mgx, and mgx we can cancel. So finally we get mgh. So at this point B, C, also we get the same term mgh. Similarly, we can find out the kinetic energy and potential energy of the object at point B. यो यहाँबाट फ्रीली फल हुँदा, यहाँबाट स्टार्ट टु फल हुँदा B मा पुग्दा त्यसको काइनेटिक एनर्जी र पोटेन्शियल एनर्जी कति हुन्छ त्यो निकालेर त्यसलाई प्लस गर्ने. So at a point B, so what will happen? So B मा पुग्दा यहाँबाट स्टार्ट भएको अब्जेक्टको भेलोसिटी अब हाम्रो B मा पुग्यो. So we can suppose let B be the velocity of object, velocity of the object when it reaches the ground, reaches to the ground. ग्राउन्ड सम्म पुग्नको लागि यो अब्जेक्टको भेलोसिटीलाई हामीले v मानौं र यो आधारमा v स्क्वायर इज इक्वल टु u स्क्वायर प्लस 2gh भनेको अब यो h नै भयो. माथिबाट यसले कभर गरेको हाइट चाहिँ हाम्रो टोटल h नै भयो. सो राइट डाउन h, बट इनिशियल भेलोसिटी इज 0, सो 0 प्लस 2gh, that means it is 2gh. So this one is the final velocity of that object when it reaches to the ground. Final velocity that केही निकै आउने भयो, इनिशियल चाहिँ 0 भयो according to the question. So now we can find out the kinetic energy, that means half, that is mass is always same, and v square. So the value of v square is, so if you put the value of v, this one 2gh को whole square, v square भएपछि whole square भयो, then we get 4g square h square भयो. त्यसमा चाहिँ oh, this is the value of v square, no, not square. So value नै हाम्रो यो v square को value हो, यसमा square गर्न मिल्दैन. So 2gh and 2 and 2 cancel. So in this way we can write down mgh. So if you find out the potential energy of that object, then what will happen? So it is mass into gravity into height. So at this point there is no height because this is the ground. Ground बाट कति height मा छ भन्नेलाई हामी h भन्छौं, तर यो ground मै भएको point भएको हुनाले h becomes 0. That's why its energy is 0. Potential energy is 0. And now we can add ke plus pe again. So ke is mgh and pe is 0. So in this way, we can finally write down MGH. So सबै रिजल्टमा हामीले हेर्दा A point, C point र B point मा हेर्दा हामीले एउटै रिजल्ट पाएका छौं यहाँ MGH. So we can see that all the results are same. That's why sum of kinetic energy and potential energy remains same. That is MGH throughout the motion at any instant. So write down the statement. So in this way we can verify the result. From all the results we can say that sum of kinetic energy and potential energy of freely falling body at any instant is same. सबैमा सेम छ यो. सेम भनेको आन्सर यो MGH अनि अगाडि यो भन्दा अगाडिको टर्म MGH सबै MGH मा छ. that means they are same, and hence same छ भन्ने बित्तिकै hence it is constant. Same हुने बित्तिकै it is constant. So in this way we can prove principle of conservation of energy. हरेक पोइन्टमा यसको एनर्जी constant हुन्छ, conserve हुन्छ, same हुन्छ. That's why we can verify this theorem by taking this example. So let's solve the practice questions. So we have this question now. A girl climbing a rope does 1320 joule of work in raising herself against the force of gravity. गर्ल्सलाई माथि रोप माथि चढ्नु छ, अगेन्स्ट द ग्राभिटीमा चढ्नु छ, यति जूल अफ वर्क उनलाई चाहिन्छ. If the weight of the girl is 440 Newton, so this is the force or weight. Find the height climbed by girl. यो यति जूल अफ वर्क युज गर्दा यति न्यूटनको गर्ललाई कति हाइट उनले क्लाइम्ब गर्न सक्छिन्, चढ्न सक्छिन्, रेज गर्न सक्छिन्, त्यो हामीले निकाल्नु छ. So in this question, this is the work done. So work is there. So work done is equal to 1320 joule. Its unit is joule. And if the weight of the girl is, so this is weight, or we can say force. Force and weight, that is same thing. So this is force. Force is equal to 440 Newton, 440 Newton. Find the height climbed by the girl. So it is height is given. So h is equal to what? So we can substitute the value of, now we can use the formula. Now we know that W, work done, is equal to force into height. So this is the formula. F into S. अब मोशन स्ट्रेट लाइनमा डिस्प्लेसमेन्ट भएको छ भने h लेख्ने, सर्टन हाइटमा डिस्प्लेसमेन्ट भएको छ भने h लेख्ने. So it is, here is height, so write down h, F into h. F means it is mg, mass into gravity. Mass into gravity into height means mgh लेखे पनि हुन्छ. So this is the formula. Work done means 1320. Force means it is weight, and the weight is 440 into height is unknown. That's why h is equal to this divided by this 440, and this means 0 cut, and this 3s are 132. So 3 meter is the height of the girl. So the height climbed by a girl is 3 meter. तो गर्लले 3 मिटरको हाइट चाहिँ क्लाइम्ब गर्न सक्छिन् यति वर्क र यति वेट छ भने. So in this way we can use the formula of work done, which is F into S or F into H. That is same thing. So apply this formula, and after substituting we get the value of H. Now we have this question, another question. So first of all, understand the question. How large a force is required what force is required? Force find गर्नुपर्ने छ यो क्वेशनमा. Which covers the distance 80 meter. 80 meter को distance cover गर्नको लागि र 800 joule भन्दा बढी को वर्क हामीलाई गर्नु छैन. 800 joule सम्मको हामीलाई वर्क डन गर्नु छ भने कति फोर्स अप्लाई गर्नुपर्छ? So how much force is applied to make this work done which covers this distance 80 meter? So let's point out the value. So we have given 80 meter is the distance, so S is equal to 80 meter. It is given in the question, provided information, or we can write down here or given. And this 800 joule means it is work done. This is work done by object or any particle. So work done is 800 joule, and we are going to find force. Force F is equal to what? So we have, or we know that F is equal to work done is equal to, the formula is work done is equal to force into displacement. So this is the formula to find the work done. It is the product of force applied on the body and displacement or distance moved by the body. So F into S. So our work done is 800 joule, 800 only, and force is we are going to find, and S means it is 80. So if you cut down, then it will be 800 divided by 80. So it will be 0 cut 8 tens are. So 10 Newton is required. So 10 Newton force is required to cover the distance. This one, if the total work not to be exceed 800 joule. यो भन्दा बढी वर्क डन हामीलाई गर्नु छैन र 80 meter distance cover गर्नु छ भने we need 10 Newton force. So in this way we can solve it by using the formula of work done, which is F into S. So we have this question now. An object is pulled along the ground by 75 Newton. So this is the force. Force applied on the body is 75 Newton. So write down F is equal to 75 Newton and directed 30 degree above the horizon. The horizontal line sanga, it makes 30 degree angle. So if theta be the angle, then it will be theta is equal to 30 degree. So यसले 30 degree को angle बनाउँछ भनेको. How much work is done by the force in pulling the object through 8 to root 3 meter? यो distance हामीले pull गर्नु छ भने, that means the distance covered by that object is 8 to root 3 meter. And we are going to find how much work done. So work done is equal to what? So this is our question. So how to find? So we know that the formula is work done. So with the help of this information, we have force, we have inclined angle with horizontal line and distance covered by body. So how to find the work done? So our main formula is force cos theta times S. So this is the formula. When force is applied in another direction, force is applied in this direction, and distance moved by body is horizontal line. Horizontal line में distance move भएको छ र force यसरी apply भएको छ भने it makes the angle theta, and at this case this force र theta को आधारमा हामी f cos theta force apply भएको भन्छौं यहाँ horizontal मा. So f cos theta, write down the value of f 75 into cos theta means we have 30. Theta is given here, and 30 s means 8 root 3. So this is the expression after substituting the value in this formula. So it is 75 cos 30 means this is root 3 upon 2 times 8 to root 3. Now we can cut down these two fossa, and 75 into root 3 into root 3 means it is 3 into 4. So after multiplying all the value, we get the required joule. Work done is measured in joule. So multiplying this one, 75 into 12. So 2 5s are 10, 2 7 are 14, 1 15, 75, 0, 0, 9. 900 joule of work done is carried out by this object. So in this way, we can apply the formula of work done in the case of inclined plane, when the angle, some angle is made by this object while moving the displacement. So this question is based on kinetic energy. So we have to find kinetic energy of this bullet whose mass is 20 gram and moving with this velocity. So let's write the information one by one. Mass is 20 gram, so be careful. Mass is always expressed in kg, kilogram. So we should divide it by 1000 and it goes to, it converted into kilogram. So this 0 cut down and 250 is. So 1 upon 50 kg is the required mass in kg. So similarly, this is the velocity. V is equal to 30 meter per second. And we are going to find kinetic energy of that bullet. So which formula is, we know that how to find the kinetic energy of that body. So Ke of this moving body or moving bullet is known as, is calculated by using this formula, half into mass into square of the velocity. So substituting the value 1 by 2 and mass we have 1 upon 50 and velocity square means we have velocity 30. So 30 go square भयो. Now we can cut down this one. This 30 go square means it is 900 divided by 52 is 100. So if you cut 0 then we get 9 joule. Energy is also expressed in joule. Its SI unit is joule. So 9 joule of energy is required for moving 30 meter per second square with mass 20 gram. So in this way we can use kinetic energy of this bullet by using this formula. So after substituting we get the required energy. Now let's see this question. Calculate the potential energy of the body of mass 5 kg raised to the height of 5 meter. Acceleration due to gravity is 9.8 meter per second square. So in this question, potential energy is to be asked. Potential energy सोधेको छ र potential energy को formula को लागि we should have mass, gravity and height. So all the informations are here to find the potential energy. So let's write the mass, which is denoted by m, and it is given 5 kg. So similarly, height is also given. So height is equal to 5 meter. And the question is potential energy of that object. So we have the formula. We have potential energy is equal to mgh. So this one is the formula to find potential energy. So let's substitute the value of m 5 times, g means 9.8 and h means 5. So if you multiply all the terms, then we get required energy, which can be expressed in joule. So 5 5 is 25 into 9.8. So 9.8 into 25, 5 8 is 40, carry over 4, 5 9 is 45, 45 4, 49, 2 8 is 16, 2 9 is 18, 1 19, 0 5, 4 and 2. So after decimal 1 number means 1 0 cut. So we have 245 joule. So this joule of energy is required to raise the height of 5 meter, whose mass is 5 kg. 5 kg mass भएको objectलाई 5 meter माथि पुर्याउनु पर्यो भने 245 joule को potential energy चाहियो. So this is the required answer for this problem. Now we have this question now. Calculate kinetic energy of the bullet of mass this 1 kg, this kg moving with velocity of this one. So to find kinetic energy, we have velocity also and mass also. So with the help of mass and velocity, we can find out the value of kinetic energy. So let's write the value of this one. So let's solve. We have the mass over here. So mass is 0.015 kg and the velocity is this one, v is equal to 400 meter per second, and we are going to find the kinetic energy of that object. So the formula is, we have kinetic energy is equal to half mv square. This one is a formula to find kinetic energy. So let's write the value. A mass is 0.015 and velocity is 400. So 400 square value. So if you solve this, all the term over here, then we get 1200 joule. So after solving this numerical question, our answer is 1200 joule. So this is the answer of only first part. For second part, we have, if the bullet is brought to rest in 2 centimeter, 2 centimeter यसले कभर गरेपछि त्यो बुलेट रेस्टमा आयो, यसले कभर गरेको डिस्टेन्स हो यो. So for second part, s is equal to 2 centimeter and we can reduce it into meter and it is 0.02 meter. Centimeter ला meter मा convert गर्नुपर्छ. So it is divided by 100 because 100 centimeter is equal to 1 meter. So this is S and find the average force of resistance. हामीले फोर्स निकाल्नु पर्यो हैन र कति अपोजिङ फोर्सले त्यसलाई चाहिँ रोक्न सक्छ, स्टप गर्न सक्छ भनेर निकाल्नको लागि F is equal to what? So this is going to find. And now again we know the formula of this work done. So work done को formula चाहिँ आउनु पर्छ यहाँ. Work done is equal to F times S. So जति kinetic energy हाम्रो use भएको छ त्यति नै work done हुन्छ. Energy capacity of doing work भनेर हामी जुन भन्छौं, वर्क गर्ने क्यापेसिटी नै हाम्रो के हो, त्यो नै एनर्जीमा कन्भर्ट हुने हो, एनर्जीमा ट्रान्सफर्म हुने हो. त्यही भएर काइनेटिक एनर्जी एन्ड वर्क डन दे आर सेम थिङ. सो वर्क डन को ठाउँमा 1200 राख्ने हैन र 1200. फोर्स इज अननोन and the distance covered is 0.02. So in this question we can find out the force by 1200 divided by 0.02. So first of all remove this decimal 02 and we have 2 matrai aayo. After decimal 2 number means we can put 20 in numerator. So if you cut down the value then 2 6 that 12 1 2 3 4 1 2 3 4 40 and force is measured in Newton. So this 60,000 Newton is required for average force resistance to resistance the wooden block. So this is the required force by solving this one. So kinetic energy and work done, it is same thing. So in this way we can solve this problem. Now let's see this question. Now a ball of mass 0.1 kg is thrown vertically upwards with an initial velocity of 20 meters per second. And calculate the maximum height reached and its potential energy halfway up. ठ्याक्कै हाफ हुँदा यसको पोटेन्शियल एनर्जी कति हुन्छ त्यो पनि निकाल्नुस् र यसको म्याक्सिमम हाइट कति हो माथि पुग्न सक्ने हाइट त्यो पनि निकाल्नुस्. So now mass is given, so m is equal to 0.1 kg. It is given here with an initial velocity is this. So initial velocity is 20 meter per second and maximum height reach भनेको त्यो maximum एउटा point मा certain point मा its final velocity becomes 0. Final velocity 0 हुन्छ and maximum height. So maximum height is h is equal to what? h चाहिँ निकाल्नु पर्यो पहिला. अब now we know that V square is equal to U square minus 2GH. Vertically upward फाल्दा हाम्रो यहाँ माइनस को फर्म आउँछ माथिबाट तल ड्रप गर्दा प्लस तलबाट माथि प्रोजेक्टेड अपवर्ड गर्दाखेरि if direction is upward from the ground then against the gravity it should be minus. So write down the 0. U square means it is 20 square and 2 into G means we have 10. Value of G is 10 and H means it is unknown. So 20H is equal to 400, then H is equal to 20 divided by 400 divided by 20 means it is 20. So height is 20 meter. So this is the formula. Height is 20 meter. And also we have the second part. P is half P is निकाल्नु पर्यो. So P potential energy stored in the body is mgh. यो half भएको हुनाले by 2 लेख्ने. So this is the formula. ठ्याक्कै आधामा जाँदा यसको पोटेन्शियल एनर्जी कति हुन्छ कति एनर्जी हाफमा मात्रै जाँदाखेरि हाफ डिस्टेन्स कभर गर्नलाई कति एनर्जी is required, we have to find this. So mass is 0.1 and gravity is 10. H means it is 20 divided by 2. What we get? So 2 5 जा 100 1 जा means 100 भयो 10 मात्रै आयो 10 joule. 10 joule of energy is required for this question. So our question, the demand of the question is, if it covers only half distance, then how much energy is required? So 10 joule of energy is required for half distance and whose maximum height is 20 meter. So in this way we can solve the problem according to the given question. Now we have this question. We can see this question on the board, whiteboard. A shot whose mass is 40 kg is discharged from the 700 kg gun. एउटा गनबाट हामीले शट फ्याकेका छौं अथवा बुलेट फ्याकेका छौं with this velocity. The velocity of shot is 140 meter per second. Find the constant force which acting on the gun. गनमा लागेको फोर्स जुन constant force लाग्छ त्यो 6.4 मिटर कभर गरेपछि कति फोर्स लाउँदाखेरि यो चाहिँ 6.4 मिटरमै स्टप हुन्छ त्यहाँ अप्लाई हुने फोर्स अथवा त्यहाँ एक्ट गर्ने फोर्सलाई हामीले निकाल्नु पर्छ. So find the constant force means force is to be asked. So this is the question. To stop this recoil, this shot will be 6.4 meter. So let's see. Now we can see that momentum of shot. We can write down for shot. For shot को लागि चाहिँ mass is 40 kg and velocity is small v, that is 140 meter per second. And for gun mass is unidentified and only discharged from 700 kg gun. So mass is given, it is 700 kg, mass is given 700 and velocity is capital V is equal to what? The velocity of the gun is unknown. So from this momentum, so here momentum of shot is equal to momentum of gun before collision. अब यो बुलेट हान्नुभन्दा अगाडिको मोमेन्टम र बुलेट हानिसकेपछिको पछाडीको कोलिजन आफ्टर कोलिजनको मोमेन्टम they are same. They should be equal. So after from principle of conservation of momentum, we can say that before collision and after collision all the momentum are same. So both momentum are same. So momentum of shot means mass into velocity. Shot को लागि mass into velocity m into b. र gun को लागि mass into velocity is here capital M times b. So this one is the formula for momentum. So for momentum we should write mass into velocity. Now use small m, capital M, small b, capital B. So the different notations are used. Now small m means it is 40, small b means 140, capital M is 700 and capital B is this one. So from here we can find out the capital B. So capital B is 0000 cancel, these two zeros cancel, 7 2 are 14 and 2 4 are 8. So 8 meter per second. So this one is the velocity for the gun. Velocity of gun is 8 meter per second. So now we can write down the change in kinetic energy now. Change in kinetic energy of the gun. गनमा आएको काइनेटिक एनर्जीको चेन्ज कति हुन्छ भनेर हामी निकाल्छौं. गनले वर्क डन बाइ गन, गनले वर्क डन त गनले गरेको, तर गनले कति एनर्जी प्रोड्युस गर्यो, गनलाई त्यो वर्क डन गर्नको लागि कति एनर्जी चाहिन्छ, वी क्यान फाइन्ड आउट फ्रम दिस वान, हाफ एमबी स्क्वायर. गन भएको हुनाले गनको क्यापिटल एम र क्यापिटल बी युज गर्नुपर्छ, क्यापिटल एम क्यापिटल बी, and we can write down the value 1 by 2. Capital M means it is 700 and capital B means just now we have 8 meter per second. So 8 को square हामी यहाँ लेख्न सक्छौं. So this is change in kinetic energy of the gun. So यो kinetic energy सबै energy हाम्रो work done मा कन्भर्ट हुन्छ. यदि हामी energy छ भने we can do the work. So it is the doing work. This energy is for doing work. So let capital F be the, we have to find the constant force, be the required force on gun. Gun मा हामीलाई चाहिएको required force भनेको capital F हो. Then we can write down work done by gun is equal to F into S. So this one is the formula for work done on gun. काम गर्ने गनले हो त जति एनर्जी यसमा चाहिँ प्रोवाइड भएको छ त्यति नै वर्क डन यसले गर्छ. So work done is here. Work done means it is kinetic energy and kinetic energy is this one. So write down 1/2 700 into 8 square from here. And force we are going to find, and S means constant distance. So this is the distance for gun, 6.4 meter. So if you solve it, then we get, then 3500 Newton force is required. So in this case 3500 Newton force is required, which acting on the gun would stop it after recoiling of this distance. यदि distance cover गरिसकेपछि त्यो गनलाई स्टप गर्नको लागि हामीसँग 3500 न्यूटन को फोर्स हुन आवश्यक छ. Now this is the question regarding the power. Our topics is work, energy and power. हामीले work र energy सँग related questionहरु सकिसकेका छौं. Now this is the question regarding to power. So calculate the power of the pump. Pump को power हामीलाई find out गर्नु छ. जसको लागि we are given this question, which can lift this kg of water through a vertical height of 4 meter. Height is given, mass is given, time is also given. And now we are going to find the power. So let's see the point out all the terminology. So mass is equal to 300 kg. This is mass. And 4 meter means it is distance. It is the height of this one. So height like S नै लेखौं. H is equal to 4 meter. 10 second means it is time, 10 second. And G is also given 10 meter per second square. And we are going to find the power. So power P is equal to what? So this is the question. So these all are the given information. And first power, the formula of power is work done by time taken. We have time over here. Time छ हामीसँग. अब work done निकाल्न बाँकी रह्यो. So let's find, first of all let's find the work done. पर सबभन्दा पहिला work done निकालौं. Now work done is equal to mass into gravity into height. So this one is the work done. That means force into displacement. Force भनेको mg हो, force र weight एउटै हो mg, and displacement भनेको height. यहाँ हाइटमा सर्टन हाइटमा अल्टिट्युडमा हाम्रो डिस्प्लेसमेन्ट भएको छ, त्यसैले h लेखौं. That means f into s, जुन हामीले पहिले गर्यौं, force into displacement, and mgh, that is same thing. And we have the value of m, write down 300 into gravity is 10 and height is 4. So 4 3s are 12 and we have altogether 30. So this joule of work done is given. And now we can find out, therefore, power P is equal to work done by time taken. Work done by time taken, and work done is 12,000 and the time taken is only 10 seconds. 10 seconds. So if you cut down the 0, then we'll get 1200 watt. It is watt. The SI unit of power is always watt. So 1200 watt is required. This watt is required for the pump which can lift this mass of water in this height 4 meter in 10 seconds. 10 सेकेन्ड में 4 मिटर हाइट रेज गर्नको लागि यो मास अफ वाटर को लागि यति रेट अफ डुइङ चाहियो. 1200 वाट चाहिँ हाम्रो रेट अफ डुइङ वर्क हुनु पर्यो. नाउ वी हैव अनदर क्वेशन. Let's see this question. A pump having a power of 294 watt. So this is power. Power is given here. So let's write down the note of this. Power P is equal to 294 watt. So this is the information for power. At the rate of 90 liters per minute. 90 liter is the mass of this one, mass of liter. 90 liter. So 90 liter means it is 90 kg mass of water, because 1 liter is 1 kg. That's why 90 liter is 90 kg. So 1 liter of water means 1 kg. It is provided information. It has already given in the question. So liter like kg ma convert garda same huncha, eta 1 huँदा eta 1 huncha. That's why 90 kg. And per minute means it is 1 minute. So time is 1 minute, but we know that time should be in second. So it is 60 second. Time always in second. Time like second में express करनु पर्छ. Its SI unit is second. And find the height. So height is equal to what? This is the height, and the value of G is 9.8. So value of G is 9.8 meter per second square. So in this way we can pick out the information one by one, and if we can apply the formula of power, because the value of power is given. But to find, before using the formula of power, we have to find out the formula of work done, because power means work done by time taken, but we have the time, but we don't have the value of work done. So let's write the work done is equal to what? mgh. This is the formula. Force into displacement, or weight into height, or weight into displacement. So this is work done. So m means it is 90 kg. Gravity, this g is 9.8, and h means the height is unknown. So let's write h. It is same. And now we can use the power. Power is equal to work done divided by time taken. Time taken. So work done means it is 90 into 9.8. Power is given, so write down here. So power is 294. Write down 294. Time taken is 60 seconds. So write down 60. And work done is 90 into 9.8 into h. So this is this one value. So after solving all the values, after cross multiplying and simplifying all the terms, we get 20. So height is here, so its unit should be, unit is meter, so height is 20 meter. So in this way we can solve the problem. So it is the question regarding to power. So we can use the formula of power, but first of all find out the work done, because after calculating the work done over here, we can write down the power. We can find out the value of power. So in this way we can solve this problem. Now we are going to deal this question, and our question is, a bullock cart is pulled uniformly by a force along a smooth plane through a distance of 20 meter in 2 seconds. 2 सेकेन्डमा 20 मिटरको डिस्टेन्स यसले चाहिँ पुल गर्छ त्यो गाडाले. सो राइट डाउन दिस क्वेसन. सो दिस इज द डिस्टेन्स. सो राइट डाउन s इज इक्वल टू 20 meter and 2 seconds means it is time taken by this bullock cart. So 2 seconds is the required time to move this distance. If the power used is 2000 watt, then we can write down power is equal to 2000 watt and find the resistance of the ground. So resistance means it is also force. So write down the, find out the value of F. त्यसलाई अपोज गर्ने फोर्स हामीले निकाल्नु पर्छ. यति सेकेन्डमा यति मिटरको तरिकाले यति रेट अफ डुइङ वर्क छ भने what force we can apply to resist this ground. So first of all we can find out here work done. We can find out the work done. So the value of work done, formula of work done is force into displacement. So this one is the formula to find the work done. So we can find out force is unknown, but displacement is given here 20 meter. So write down 20. Then therefore we can use the formula of power. Power means it is work done divided by time taken. So we have the power, this one 2000 watt is equal to work done is F times 20 divided by time taken means it is 2. And so after solving this 2 tens are 20, and if you 10 means 0 0 cut down, so F is equal to 200. This 0 and this 0 cut down, therefore force is equal to 200 Newton. So this force means 200 Newton is required to resist this power. So this is the resistance of the ground by using this formula. So first of all find the work done, then after power taken by, power means rate of doing work for this work done with the help of this information.